Okay, so we're looking at page 15 in the Unit 1 packet. This is lecture 1.3. So we're talking about other regressions, other types of regressions, aside from the linear function. So we're talking about quadratic, cubic, quartic, exponential, and natural logarithmic regressions. Some are easier to compute than others, but they're all basically doable using the Desmos calculator. So that's the first adjustment that we're going to make here, since we're doing this online. This is going to be using the Desmos calculator. All right, and so I'm going to show you a different way to handle these kind of computations than you might see in an ordinary stat class. All right, so first thing we're going to have to do is identify which variable is the x variable and which one is the y variable based off of the context of the situation. Most of the time it's the first set of data that you see, and then you just go from there. But that's not always how it plays out. So you just gotta carefully read the problem, right? So a study was conducted to determine if there's a relationship between the number of brownies eaten on a daily basis and an individual male's weight, right? So if there's gonna be a cause and effect relationship, not guaranteed, but if there was gonna be a cause and effect, which do you think would cause, which variable do you think would cause the other to happen, right? So would the number of brownies that you eat on a daily basis impact your weight? Or would your weight impact the number of brownies you eat on a daily basis? Now, there is some sort of interaction between the two. It's just a question of which one is more likely to cause the other to happen. From my viewpoint and my love of brownies, I would tend to think that it's the brownies that would cause the weight gain or loss, depending on how many you eat. All right, so the x values would be corresponding with the number of brownies eaten daily, and the y value would be corresponding with the weight in pounds. All right, so let me get rid of this information here. I got this from another class, a new blank graph. Hit the plus sign to input some data. All right, so table. I'm going to type in my stuff here, 12. Oop, that's not a 13. 13, 22. You see it autofills. I did 12, 13. I wanted to put 14 in, but I said nope. Not consecutive values. Next one is 31, 41, 53, 65, 73, 83. There's a lot of brownies. And obviously you can tell that this is a made-up scenario. Because I mean, if it's possible to eat 99 brownies on a daily basis, I can't really fathom that. But if it's possible, I'd sure like to shake the hand of the person. No, 195, 205, 225, 250, 295, 310, 310, 325. So then locked it all in. Let me double check. 12, 120, 13, 140, 22, 170, 31, 195. Yep. 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 And yep. All right. So we have all our information in. We could figure out a linear regression equation, but the first question says determine using your calculator the best regression model. All right. So which one is it? You know, is it quadratic, cubic, quartic, exponential, natural logarithmic, or maybe it's the linear regression model? I think it all starts with maybe we should have a look at the scatter plot and see what's going on there. Now this is a default negative 10 to 10 window, so let's pinch out and see if we can find some points. At first glance, you know, if you look at it far enough, you're like, oh, linear. But then when you look closelier, even more closelier, you kind of see some nooks and crannies, some dips and dives and guts, and, you know, all that stuff. So maybe it's not linear, right? So let's investigate. Now, how do you do quadratic cubic? That is the big question. If you know the model, the general form of a quadratic equation, then you know how to do it in Desmos. All right, so linear, for example, we were saying is equal to y, or is y equals mx plus b. You know, that's a linear equation from years ago. But we kind of, we adjust that. Instead of the m, we say the a. And instead of having the slope component come first, we have the fixed quantity come first, because that's your starting point. And then any change associated from that is accounted for. So we're really looking at this swap. And so we have y hat. Y hat is just talking about a prediction model. All right. With a plus bx, where a is no longer taking on the role of slope, it's the b that's the slope. A little too tightly grouped there, slope. And the a is your y-intercept. I'll put a dash there. Otherwise it's like, what's a yint? All right. So then we also talked about, okay, well, that's all well and good. How does Desmos understand this? The Desmos interpretation of it, we talked about this last time, or earlier tonight, depending on when you're watching this video. In Desmos, we use the notation that the table uses. Instead of x's and y's, they're using x1 and y1. Instead of an equal sign, we'll use a tilde, which represents in Desmos to regress to a particular form, but everything else is going to stay the same. So a plus b x1. All right, so that's the linear case. And that's a lot of rehashing stuff that we've already talked about. All right, so that's kind of, it's why we're here, but it's also not why we're here. What we need to do is modify what we already know about quadratic equations. Now, I understand it may be a little fuzzy for some of us. And also, I want to be realistic. It may be non-existent information for some of us too. You know, if it happened so long ago that you studied quadratic equations, that it's kind of like, yeah, I know I learned that at some point, but dude, I have no idea what the heck you're talking about. And you might as well have never learned it, right? That's the case of a parabola, you know, a curve, that a U-shaped curve or an upside down U. But regardless, it's in the form of y equals ax squared plus bx plus c. All right. So what do? Well, we do what we did for the linear case. Any x and y, I'm going to put a little subscript of 1. And instead of the equals, I'm going to use a tilde to regress. Oh, I regress. No, it's digress. I know, but still. I'm just being silly. Anyway, the cubic case, so that's the model. If you know that model, then we can run the regression model. Model. 2 times in the same sentence. A new world record. Cubic is a power of 3. So it's got the same structure. It just starts off with the power of 3 and declines from there. This one started off with the power of 2 and declined from there. So I'm just going to do a little copy-paste job. Copy, paste. but this is now going to be a power of 3, power of 2. The next one has to be a power of 1. So x sub 1 to the first power, which, you know, I'm not going to write it to the first power. But then you see how we have a loose constant here of c, of plus c? Oh, we got to go down to the one that has no x attached to it, or x to the 0th power. And so in this case, it would be plus d, lowercase, actually. So that's a cubic case. We got to type all this stuff in? Yeah. Yeah, it stinks. I would not want to be you, I'll tell you that. No, it's you just do it the one time, and then you save your work and replace the data. Right? You get used to that a little bit more and more as we go through the course. Right? So Quartic is the same idea as a power of 3, except you're starting off with a power of 4. Oop. Deleted the wrong dang thing. All right, let's go purple for those keeping score at home. So 4, 3, 2, 1, I'm not going to write the 1, and then plus E. So that's a Quartic case. Now, if you wanted to stop there, you could with Quartic, but you can go to Quintic. You can go to power of 40 if you want. There's a lot of variables to write. But again, this is quadratic, power of 2. Power of 3 for cubic. They're all polynomials until we get to the exponential case. Power of 3 and power of 4. I guess I didn't have to write this so close. Bring it back. The exponential is a particular variety of exponential. It's exponential base e. That's the one that we use. You can use base 10 if you're familiar with exponential functions. You don't really have to be too much in order to be able to write one. They're always going to be in the form, at least for our purposes, of y1 tilde a times b, e, that's what I meant to say, to the b x sub 1 power. All right, so we want to allow for a coefficient in front of the variable in the exponent. All right, that's one of the trickier models because there's so many different ways to represent it. And also, if you're not overly familiar with exponentials, that doesn't really have too much meaning for you right now. So that's just kind of how we leave it in terms of an explanation. This is one of those, you just do it. All right, there's other forms of an exponential, but if we want to have the most useful kind, we tend to go with a base e. All right, and you look at that and you say e as in like this e? No, this one is it's different. It's where e is approximately 2.718. So it's an irrational number, much like pi is approximately 3.14-ish. E is an irrational number where it's approximately equal to 2.718-ish. Right here, for all of these, A, B, C, D, E are constants. But really, they're serving as coefficients. So they're constants, but they're serving the role of coefficients. They're the values that we have to figure out. All right? Same idea for the A and B there. It's just E we're using. It's doing double duty. And then the last one is the natural logarithmic, where we would say y1 is equal to A times the natural log, ln, of B x sub 1. right, allowing for a coefficient of x sub 1 again. All right, so definitely, it took a turn into the weird realm here, but it's still very manageable. I'll show you. It's just a lot more typing than maybe you would have liked. If I were you, when I'm creating my own Desmos calculators, and I've hopefully mentioned it enough by this point, that's what you should be doing. You should be, when I create a calculator, you either take the ones that I make available on Blackboard, or if you're in my high school class, Schoology, and save it in your own account, title it anything you want, edit it, tailor it to your own needs. But ultimately, you want to be working with these Desmos calculators. All right, so first one that I would put in here is linear, and you know what? Right off the bat, I'm going to put a little note here. Linear. And you know, you can type the whole thing, regression equations and stuff, but that's up to you. Y1, tilde, you go into the alpha, the QWERTY pad, look for the tilde. A's in the QWERTY pad still, plus back to the QWERTY pad. Kind of wish they had just the 4 functions in the QWERTY pad also, but you can't have everything. Bx, but then you're like, nothing came up. Bx sub 1. So if you type the 1 after it, it knows that you're talking about a linear regression model, so it knows that you're referencing a table, and since the tables have subscripts, it assumes that that's what you're trying to do. All right, so the first thing I would do is make a note for the linear case. We're going to report the R squared values. All right, so I'm actually going to smidge this down a little bit and just identify the R squared values, 0.972. I'll go, it's only 4 decimal places, I'll put them all. All right, why not the R? Because some of the other regression models don't have R's, or at least they don't list R's. So if we want a basis of comparison, we'll look at the R squared. The R squared value closest to 1 wins. As simple as that. All right. Not to say that that's overly simple, but it's as simple as that. So enter, that's locked in, save it. All right. You have your regression equation, but I don't know if this is the winner yet, so I'm not gonna call it at this point. Quadratic abbreviations, as long as they're obvious, are fine. So I'm gonna type in first quadratic. On paper, I'm putting an abbreviation, but on Desmos, I'm gonna put the whole dang thing, especially since autofill is a thing. Y1 tilde ax1 squared plus b x1 plus c. You see it reports an R squared value. It's a capital R squared. There's a reason for that. We'll get into that down the line. You don't really need to know at this point the difference, except to say that there is a difference in meaning, but not in practical use. So we're looking for an R squared lowercase or R squared uppercase. Either way, the one that's closest to 1 is the one that wins. All right, and here we have an R squared 0.9762. All right, now we need to get to a cubic. So note, type it in, cubic. Oh, helps to type it in, and then hit enter. Now what I'm going to do is I'm going to do a little duplication here because I typed a lot of stuff. I don't want to have to type it all again. Type some of it again, but not all of it. All right, this one is going to be a power of 3, power of 2. I still got to type, like I said, but now I feel like I'm typing less. And then plus D. All right, so the duplicate, and then just go back and correct as you go. The one thing is, since it is a duplication, it took the color of the quadratic and it made that the color of this. If you don't like that, just long press and change it to something else. All right. So cubic, about 0.9. Let me just make sure I typed it in right. B, C, D. I typed everything. So cubic. Trying to kind of be consistent with my color scheme here, but that's all right. I've given up on that. About 0.9675. All right. So if I had to call a winner at this point, oh, time out, time out. I found my mistake. YouTube is screaming right now. That's not squared. Phew, Jackman. I avoided one there. 0.9762. All right, so it looks like linear is out. That's not the winner. It's not as good as 9762, but now it seems like I have a tie between quadratic and cubic. So let's move on to Quartic. So, yeah, see, that's the danger of duplication. You edit something the wrong way and it's all over. But that's usually a me problem. Seems like I'm the only one that ever messes that up, so go for it, I say. Quartic. Then I'm gonna do it again. I'm gonna give it a shot. The old college try. All right, so this should be a power, back, power of 4, power of 3, deleted when I should have backspaced, power of 2, we want x sub 1, power of 3, power of 4, 3, 2, 1, and then plus an e. We got an R squared value that's about 0.9931. That is the clear winner so far. All right, so if you want, you put like a big old strike through between, or for each of these to indicate that you've eliminated them as values or functions that would be in contention for the final answer. Again, it's we're repeating colors here, so maybe kind of bring this down the line, maybe make it purple, maybe turn off the other ones by tapping onto their graph icons. And you can see that it seems like we got a pretty decent fit. I don't know if contextually it's going to be the best option, but it seems like we got a pretty decent fit. All right. Exponential. Exponential. So y1, this one I'm going to take from scratch because there's not enough similarity between it and the other models to make it worth it to try to do a duplicate. It pretty much delete everything. A times, and by the way, you can create a model based off anything you want. Create a model in the shape of a Mobius strip inverted. Give me those two eigenvalues over there. Quote, anyone? So times E, Desmos knows what E is. All right, raised to the, I want B, and I'm going to put X1. All right, it asks you if you want the log mode. We don't mess with that. All right, all we want again is the R squared value. So exponential. Nope, didn't turn off my line draw tool. All right. That's definitely not the winner. It's not as good as the other ones, but we gotta look. Natural, logarithmic, rhythmic. And so that model, y1 tilde, Swindon, A times you type in ln for natural log, log natural, open parens, b x1. Again, I'm gonna ask you if you want a log mode. We're not messing with that. We're just here for the r squares, that's all. Natural log. That's about 0.9389. So these definitely, they're not as close to 1 as the Quartic is, so Quartic is our winner, right? But now we have a record of all of our work, all right? So I'm going to turn off the ones. I'm not going to delete them because I want to save this. I want to save this calculator, all right? I'll do that at the end, but I now have all of my work just in case I want to toggle back and forth. But more importantly, I have the winner, all right? Y1. Now, it is a true joy to write this equation down, all right? So this one is the best model. Because, oh, why do I even try to write in cursive anymore? Because r squared is closest to 1. All right, showed all our work, that's good enough. Determine the equation of best fit. We got, all right, so y hat is how we write it in statistics notation. Regardless of what Desmos says, we still got to put it in the right form. So we got to write all this stuff down to 3 significant digits. If you want to use scientific notation, that's fine. In this case, I don't think it's necessary. I don't see an E value there. But it's entirely possible let me just check something real quick. Yep, it thought it was the exponential E. All right, so we got to use something else other than E. So we have to skip a letter in the alphabet here, folks. We got to go with an F. Huh. Okay, well, you know what? As terrible as this might sound, just think of the grading system. You know, the college grading system. What are the possible letter grades that you can get? A, B, C, D. There is no E. You go right to an F. All right, so that's a little mnemonic device that just came up with right on the spot. But that was my alert that something went wrong here. It didn't affect the correlation because it was still a Quartic model, and it still would have coefficients, but you'll notice once I made that change, the actual values of the coefficients changed. So they're, you know, important enough, but you still would have gotten an accurate equation. It just would have been not in the appropriate form. All right, so we're looking at, again, it's ax to the fourth, so negative 0.0000. Again, you can go scientific notation if you want, but I don't think it's necessary here. 268 x to the fourth plus 0.00591 x to the third minus 0.440 x squared plus 14.975 plus, just checking my signage here to make sure I didn't botch anything, 0.0711. All right. So that's a lot of writing, and you know, I can already imagine the huffing and puffing of like, oh my God, this is so much. Anybody who truly feels that way, I'll offer you an appointment to meet with me and I'll show you how to do all this stuff by hand. All right. I was pausing for dramatic effect right there. All right, so part C, what weight would you expect a person who eats 100 brownies per day to be? Okay, well, now we're kind of in a different neighborhood here, right? We don't want to have to do all of this work by hand, all right? There's only so much we're willing to do by hand, and it seems like we did a lot. So what we do now is we save our calculator, all right? We save it, okay? So this is Regression Analysis. And it'll be posted up on Blackboard. I don't need to duplicate it, I just need the original copy. All right, so we're gonna keep that. So then what we can do now is we can feel secure in knowing that we have all of this information locked away. Any changes we make, as long as we don't resave it, we can save it as something else, but as long as we don't resave it, we're gonna be okay. So what I'm gonna do is I'm gonna get rid of all the stuff I don't need. All right, I don't need quadratic, cubic, quartic I need, exponential I don't need, natural log I don't need. I just need this one. All right. I'm not going to tap save. What I'm going to do is I'm going to say example 3. And I'll make a better title for it later. But I'm going to save it as something else. That's my point. All right. Why? Because what I want to do is I want to write this in function notation. All right. So I'm going to write this as, f of x equals all that, I don't need that, all this stuff, but in Desmos. All right, so I'm going to type that in, but I'm not really going to type it in because Desmos knows what the letter A is now. There's no confusion. When I had all those other functions in there, it didn't know. Am I talking about the A from the first problem, from the linear regression, or the quadratic, or the cubic regression, or am I talking about it for the quartic? Which A? Desmos is like, please tell me which A. Now it knows which A because there's no confusion. All right, but what I'm going to do is I'm going to duplicate. I'm going to replace every x1 with just a plain old x. All right, it takes a little doing. It's pretty frustrating. I would think we'll all agree on that. Okay, because you see these little boxes still show up. So you may have to wipe more than a couple of things out. And you might end up taking out some of the exponents as you go, but it's all right because you can just type it right back in. All right. Make the tilde an equal. It'll ask you if you want sliders. We don't. And then you could leave it as y, but I recommend making it an f of x. All right, good old function notation. So I'm just going to go across the board and make sure everything is the way I want it to be. Ax squared, ax to the fourth, plus bx to the third, plus cx squared, plus dx, plus f. Because f is what we used before. All right, then it gives us a nice error message. Oh, can't use f. Apologies, I already used f. Can't use the same variable more than once. That's the confusion I was talking about before. So call it something else. Call it g of x. All right, then hit enter. It's locked in. All right, so why is that important? This expression right up here, this Desmos notation, is designed for Desmos to create a graph. You can't operate on that. All right, so you can't do math to that. But the one that we just created, g of x, same thing. All right, no matter which one I have on or off, they're both going to the same location. But this one, I can actually manipulate algebraically. All right, so in part C, it says what weight, now weight is a y value, right? So what weight So in C, it's saying, what y would you expect a person who eats 100 brownies per day to be? Who eats 100 brownies per day? So what y would you expect when x is equal to 100? All right. Now, you gotta be careful about the words like would you expect. It makes it seem like I'm interested in your opinion. It's just actually more like a lack of a better way of asking. All right. Expectation, prediction, that's all part of regression. It's why we do it. All right. So would you expect something to occur is, or whether or not you would expect something to occur is based on what kind of regression model you have. All right. But they're telling you to figure out what y is when x is 100. So simply put, what is y when x is 100? In notation, that translates to f of 100, not f times 100, f of 100 equals what? Okay. Now in this case, the notation is like all over the place because I'm saying f of x, but then in Desmos I say g of x, but I'm talking about the same thing. If it makes you feel better, you can call it b of x for brownies. No, you can't because I already used b. We can make these g's to be consistent with what we have in Desmos, but ultimately whatever you put in here, it doesn't matter because it's just a name for the function. All right. So all I would have to do is say, all right, g of 100. And I get a result, rounded appropriately, of 321.524. All right. There's a lot going on with this page, but if you save your work on Desmos, there's a lot to build off of, and you can make a lot of use out of the stuff that we did today. All right. It's just a lot of work for now, but the next time you do a problem using these calculators, it's going to be a whole lot easier. All right. So you want to look on Blackboard under calculators on the left side, the left pane or panel, depending on what the right word is, and you'll see that there's a new calculator there called Regression Analysis.